free. There were no earthworms of any kind. And the forest actually looked different. Looks different when there are no earthworms. And especially the sugar maple forests. Sugar maple forests in earthworm-free condition are known for having this very lush, very green, very diverse understory plant community. And that understory plant community can change really quickly when worms invade. When worms invade and they heavily impact a site, you can go from this very lush understory to one that maybe looks more like this, where you've got large patches of bare soil and maybe just a few plant species. Has anybody seen forests around here that look more like this than the previous picture? Yeah. And do you still have forests in this area that look like, oops, that wrong way. All right, now I'm really in trouble. You still have forests in your area that look like this?
Few.
Pardon? A few. It sounds like your students found some that were truly earthworm-free. And the key feature of those earthworm-free forests is what we call the forest floor, or the duff layer. This is about a 4 or 5 inch thick layer of slowly decomposing leaf material. So every fall, all the leaves fall to the forest floor. And if something doesn't eat them, what happens to them? If something doesn't eat them, what happens to them? Yeah. They'll eventually turn to soil, but so if something doesn't eat them, what turns them to soil? Any guesses? Just kind of happens, right? Well, if there's no worms to eat them, then somebody else has to do the hard work. Yeah.
They rot?
Yeah, they rot. And what, does anybody know what organisms cause rot? What organisms cause rot? They're the ones that rot things. Huh? Yeah. Yeah, feed him answers. Go ahead. Yeah, come on. Yeah, molds, fungus, bacteria. Don't really think of them. Percolate down into the soil. It's a skin irritant. Just like when you eat a chili pepper, it irritates the inside of your mouth. Mustard irritates the skin of the worm. Doesn't kill them, and if you wash it off, it won't hurt them. But it irritates the heck out of them. They don't like it. And so they come up out of the soil to avoid it. And then you can collect them and identify them. So it's a way to drive worms out of the soil. It's really cool. Aside from being a very effective scientific way of sampling your earthworms. And so we did that across this earthworm invasion front. What's a species? Can you tell me what a species is? What the heck is a species? Is a bear a species? Yeah. Is a deer a species? A fresh surface layer. Whereas these guys they live and hang out up at the top of the soil. They don't burrow deeply at all. And then last but not least, we got, everybody knows that one, right? Who's that? How many fisher people we got here? Do you use worms when you fish? Which ones do you use? Some more fishermen? What do you use when you fish with worms? Oh, you use minnows. Okay, good. Okay, anybody use worms when they fish? Well, he's fishing for, when you're fishing with minnows, what are you fishing for? Walleye. Of course. Yeah. Good fish. Yeah.
I fish with those night crawlers.
Yeah, night crawlers. Bingo. That's what that is. The night crawler. It's the largest one, and it's a deep burrowing species. It burrows very deeply into the soil. It can go 6 feet or more into the soil. Who's 6 feet tall here? Stand up. Stand up, please. Okay. So, the night crawler can burrow all the way that's pretty dang deep. And in fact, that's how night crawlers often overwinter. They burrow down below the frost line so they can survive the winter. So they form these vertical, unbranching burrows, but they feed on surface litter that they drag into their burrows. And as a result, they make these things called middens. And maybe when we're out and about, we can try to see if we see any middens. They cast or poop around the entrance to their burrow, and they're dragging all this organic material in, and so a lot of times the mouth of their burrow gets jammed with leaf petiole, leaf stems, and leaf veins and stuff like that. So once you learn what a midden looks like, all of a sudden you can start to see them, and you can actually, because there's one worm, one night crawler per midden, by counting the number of middens in an area, you can estimate the population size of night crawlers without ever even seeing them. It's pretty cool. So what we found in these forests was that we saw not just one species, but a whole suite of species. And the big impacts where we really started to see areas that had big patches of bare soil and very few native plants left, those areas tend to be areas that had all of these species together. If we have only one or two species, the impacts tend not to be as big. But it's the sites that have lots of species that seem to be more heavily impacted. And that's because each one of these is eating something different, slightly different parts of the organic layer, and they burrow differently, and so the combination of all their effects is what leads to these really big effects in the forest. So what are some of these? I'm just going to show you some pictures of what some of these effects are from a fully worm-free area to a really heavily impacted area. Okay, and realize there's a continuum. There's forest conditions everywhere in between, but I'm going to kind of show you the extremes. So this is the worm-free forest floor. You remember how thick I said that could get?
1%.
So I know where it's called dot worm.
That's joking.
And what we looked at, we established 4 sites in the Lake forests. And we put plots on each site, and then we sampled from those plots, and we did soil sampling, and DNA sampling, and worm sample. And then what we did with our worms is we put them in rubbing alcohol, and it kind of kills the worms, and so they're preserved. We bring them back to the lab at BSU, and we look at all the worms, and we try to, this year we got really good at classifying the different worms by their different characteristics, such as like the setae, which is the little bristles on the worms, and then the cleptellum, and then the different specific names of worms.
That's about it. You pretty much said it all.
What about the bar graphs on there? Tell a little bit about the difference there.
Site 2 and Site 3, those are the sites that we found the most earthworms at. Like Site 1, we had no earthworms, and Site 4, I think.
We had a, Site 4, we had like these really tiny little worms you could barely even see, almost transparent. And they were from like the juvenile family, and it was kind of hard to tell which type they were because they were so small. And I wish we had them here to show you guys, but we don't. So they're back at BSU. And then we looked at years 2007 and 2008, so we kind of compared the 2 years, and we found that there were most of the earthworms we found were in 2008 this year because it was a wetter year than last year, so we found a lot more worms then. And this is these little graphs. This is like the juveniles. We found the endojig and the epijig species.
I think there's a question up front.
Oh.
Where were your sites at?
We got Site 1 is on the South Boundary Road, and then the other 3 sites are on Highway 15.